equipo Guardians of the Hurricanes con la escuela de St. John's School y el tema Airbag Injury Prevention.
Hello, I am Robert Sims, and we are the Guardians of the Hurricanes. I, along with my partners Mary Jane Sims, Nicolas Cid, Jeremiah Ramos, and Salvador Gomez, I want to talk to you about our project, Airbag Injury Prevention. We use this video to help us understand what a frontal collision was and to help us understand the engineering of an airbag.
Robert.
El airbag también, en 7 o 8% de los casos, te puede dar efectos secundarios que pueden ser thermal burns, chemical damage, contusive trauma, concussions, and brain swelling.
We studied the engineering branches that had to do with the airbag design and system. They are mechanical, chemical, computer, material, manufacturing, and electrical engineering. The airbag has 3 parts: the airbag, the sensor, and the airbag inflation system. The airbag is the bag that saves you or have you get less damage in a car crash. The sensor is the ball that's in a box that when the ball hits the sensor, it sends an electrical message to the computer and it senses when you crash. When you crash, the sensor sends a message to the computer and the computer lights the igniter so that potassium nitrate and the sodium azide light and they create a hot pulse of nitrogen gas to inflate the airbag. And that all has to happen in 1/10 of a second.
As part of our project, we researched the laws of motion to understand the physics of a car crash. Laws of motion by Isaac Newton. Law 1. An object at rest will remain at rest unless acted upon an unbalanced force. In our case, the unbalanced force is the wall. Law 2. Force is equal to mass times acceleration. Law 3. To every action, there is an opposite and equal reaction. Physics of a car crash. This is a sketch we made of the physics of a car crash. This shows the time we have for the airbag to inflate. Challenges engineers face in airbag designing. The airbag parts should be able to read and differentiate major and minor collisions, know the timing needed for airbag to activate, know the positioning of the airbag and propellant, hold gas, inflate and deflate quickly, and control chemical reaction of propellant.
Our project's hypothesis. Now we wanted to look for alternatives for the exothermic reaction that occurs when an airbag inflates to prevent some of the injuries that occur. The deployment of a car airbag occurs as the gas rapidly expands because of an exothermic reaction. An exothermic reaction is a chemical reaction that produces heat. For the bag to deploy, an explosion takes place, which in turn creates hot gases, mostly nitrogen and some carbon dioxide. Other chemical compounds are also produced in the form of aerosol spray. The spray is the sodium hydroxide, which is highly irritant and is the main cause of chemical burns. All of these chemicals come out through the deflation hose. Thermal burns can also occur from direct skin contact with hot gases or the heated airbag itself.
An alternative way of expanding gases is an endothermic reaction. An endothermic reaction absorbs heat as compressed gas expands. Originally, airbags were conceptualized to be made of compressed gas such as CO2. Originally, challenges such as cost, lifespan of cartridges, noise, and varying temperatures made engineers move from endothermic processes to using controlled explosions of solid rocket fuel. We think the re-engineering airbags to use expanding gases could be a safer alternative. Here's a video explaining an endothermic reaction.
We are going to inflate the bag through an endothermic process, which is the expansion of the gas, CO2 in this case. The result
by changing an exothermic reaction to an endothermic reaction inside of the airbag, we can remove some of the injuries that happen to you. Thank you.
Es que ahora si me pongo esto, no sé, no lo veo.
How you can, okay, how can you tell me you can get a better airbag without damage?
The endothermic reaction absorbs the heat, and you saw the thermal burn picture. That's what happens when you get burned, when the bag blows and it actually rips open and the air comes out. So if we change it from an exothermic, which is hot gas, to an endothermic, which absorbs the gas, it will make it like room temperature-ish or a bit colder, and that stops the heat. And the heat can also cause you chemical damage in your eyes, and you can also swallow it. But if we use CO2, which is what we did in the experiment, it's completely safe. It's like water. It's water vapor, so you're not going to get like any chemical damage.
Because what inflates the bag is the sodium azide and the potassium citrate, which creates a hot pulse of nitrogen gas, which burns you. The airbag doesn't just have the gas problem, it's also the nylon that they use to make the bag is actually nylon, which the nylon can hurt your face, but it's not just the chemical, but we didn't. It's just focused on.
We focused on the chemical.
That's why a lot of people when they crash they get like rashes and abrasions. Yeah, it just heals off your skin.
Pero, but
¿Cómo hicieron para decidir sobre esto?
Votamos porque
¿Dónde ustedes identifican
En el diáplico de los segundos hasta que tiene el airbag para explotar. Porque cuando choca tienes como 300, no, espera, va 330 metros por segundo. Así que tienes que saber cuántos segundos ese es del physics department.
Los detalles no es importante, pero sí en el cálculo de la velocidad, del campo.
Porque tienes que pasar todo lo que le dijeron.
También lo que tenemos que hacer es medir la distancia de la nave volante y el volante a la pared, a la pared del carro, porque así a esa distancia sabemos en una fórmula bien complicada, sabemos cuán rápido tiene que pasar, porque la cabeza va hacia el frente. Igual si tú vas a 60 millas por hora, tu cabeza va a ir a 60 millas por hora por el cambio de gravedad que tenemos hacia el frente. Así que así no sabes cuán rápido tiene que ser el airbag que responde para no caer en la cabeza.
¿Tienen idea más o menos dónde se colocan esos sensores? ¿Tienen idea dónde se colocan?
Sí, detrás de los, behind the gogs, the gauges that you have, I think it's behind there, behind the steering wheel, so it goes through the steering wheel.
¿Qué tipo de material sugieren que se hagan los airbags?
Eso yo
Porque ahora mismo usan nylon, right?
Sí, pero nosotros nos enfocamos más en el gas, porque el gas es que te puede quemar y causarte mucha...
Y así de saber, aunque es más caro, pero es muy caro. Meter lana en todos los carros es caro,
Pero sería una solución.
Buenos días. Buenos días.
¿A quiénes entrevistaron para este?
A un señor que trabajaba en el Instituto de Acura, y entrevistamos a Eduardo Matos, que está ahí atrás. Ricardo Matos, y a sus amigos que estaban también, y a él,
A tu papá. ¿Cuánto tiempo tardaron en hacer esta investigación?
3 semanas, 2 semanas.
2 y medio, yo creo, por ahí. ¿Cuántas horas?
Como que
Como 3 horas por cada día.
Pero 4 como 4 cada. Sí, pero no fue
Ayer estábamos desde las 3 a las...
Hasta las 7, no, hasta las 9 una vez.
así, bueno, la otra noche, un día de semana, yo llego a mi casa y yo, como yo no he comido ni
Yo llegué a mi casa a las 10.
La aprendieron mucho.
Sí, pero fue una experiencia muy buena, ya.
Sí. Te notas.
Sí, yo pensaba
que lo disfrutaron.
yo pensaba que y aprendimos de la mecánica también de Airbag, porque yo pensaba que era que al frente había un botón que cuando chocaba eso comía y bajaba y lo que hacía es que
Sí, no, es lo que yo creo que también.
sí, pero es una bolita que con el sensor y se le manda una corriente después hace una reacción química y
Yo pensaba que era solo aire, yo pensaba que era aire de afuera que después lo explotaba.
ajá, yo también.
Que el air conditioning fue. Yo ni sabía que daba aire. Pensaba que era
le damos un aplauso a este equipo, por favor.
bueno.